So how many rods are given? Here 3 rods are given as you're looking in the diagram. So I'm arranging the 3 rods as you're looking here. This is the first rod, and this is the second rod, and this is third rod. 3 rods are arranged, and first rod is having charge 3q, and last one is q. Both are separated by distance of d as per the question, and middle one is also kept one rod having charge q, and the faces of this contains the charge q1, q2, q3, q4, q5, q6 as per the diagram, as the charge is going to be distributed. Now they are asking to find the value of q3 and q5 value. So first, to solve this one, you take the concept of whenever you take any conductor which carries the charge, which contains the charge will be distributed among the surface of the rod. In this case, if it is a conductor, inside the conductor electric field always 0. So in this case also electric field in the case of first rod is equal to, I can say E1 is equal to 0. In the case of second rod also electric field inside is equal to 0. In the case of third rod also electric field inside is equal to 0. Using this concept, I can able to explain the required answers for our questions. In this case, they are asking Q3. Q3 means that is related to second rod. So you take the concept of electric field intensity at the center of the inside the rod is equal to E2 is equal to 0 concept, you take it, and using that you can able to explain. Now electric field at this point is 0, okay, but there are different charge distributions, different charges are surrounded by that middle rod. That means the Q1 contribute the electric field at that point of 2, that is E2 point, the second point, and Q2 also contribute the electric field, Q3 also contribute the electric field, Q4 also, Q5 also, Q6 also, everything, okay, all the charges will contribute the electric field at that point. So Q1, Q2 together, total charge is 3Q. So in this case, to understand here, I am taking the point here, that is second point. In the second point, the 3Q, total charge Q1, Q2 together, total charge is 3Q. The 3Q contributes the electric field in this direction as E1. I can write. This is the first rod, second rod, third rod based. Next, if you come across the case of second rod we have a third charge is there, Q3. Okay, that Q3 contribute the electric field. Q3 contribute the electric field. The point, okay, the charge is towards the left, so electric field will be towards the right. So that means this is the direction of the electric field due to third charge, that is Q3. E3 I am writing. Next, Q4 charge is there, that is also contributes electric field at the second, okay, center of the rod, but this is towards right means electric field will be towards left side direction. That means in this case electric field due to fourth charge is E4 in this direction. Next, if you come across case of this one, the rod which is the last rod, the total charge of Q5 and Q6 together, Q contributes electric field towards left side direction. So I can say here this is the electric field, you take it as E5. The total electric field due to this one is E5. So otherwise, if you are getting confused regarding this one, you can write as in the place of A, B, C, you take it. That is better, okay? Because here also 1 to 3, in the charges also we have a number 1 to 3. So you take this rod as A rod, this rod as B rod, this rod as C rod. So I can write the electric field due to 3Q is equal to nothing but I can write as EA. Electric field due to third charge I am writing as E3. Electric field due to fourth charge I have written as E4. Electric field due to total Q5 and Q6, that is nothing but C charge, okay, that is EC you can write. Now what is the concept here? At E2 point total electric field is 0 we are saying. So in this case simply you add all the things, that is equal to nothing but what I can write, E3 plus EA minus EC plus E4 is equal to 0. That is equal to E2, that E2 value is equal to 0. So what is E3 according to concept? Electric field due to a rod is equal to nothing but sigma by 2 epsilon naught is a concept. So that is nothing but in terms of charge density I have written here, and in terms of charge that is Q by A into 2 epsilon naught is a formula for that. So apply, if you apply this concept, In this case, A is the area of cross section, 2 epsilon naught is constant. So for every conductor it is a constant, that's why we no need to take. So electric field is proportional to charge, I can say. E3 is the electric field due to third, okay, which one? 3q charge. 3q charge means that is, sorry, E3, third charge. What is third charge? That is Q3 charge. Plus EA, electric field due to A rod. A rod is charge how much? That is 3q. So I can write as 3q. Minus EC, electric field due to C rod, which is C, this is the C rod. The charge on that one is equal to cap PQ. So I can write as cap PQ. Plus what is E4? Electric field due to fourth charge. This is the fourth charge. Okay, this fourth charge electric field is towards the left side. That is nothing but Q4 is given. Is equal to 0. So 3Q minus Q, that is nothing but I can write as Q3 plus Q4 is equal to. Here one thing we did the mistake. Q4 is what direction? Towards left. So you should not take plus here. This is minus here. Take minus Q4. The formula also we have to take minus here. Both are minus. So based on this one, I can write this one as minus is equal to 3q minus q, that is 2q. That 2q will be, if you make it that side, that becomes minus 2. So you got one concept here, that is 3q minus 2q is equal to plus 2q. That plus 2q I made that side, it becomes minus 2q. So now to get the Q3 value, this capital Q, that means second rod, B rod total charge is Q, that is a combination of two charges Q3 plus Q4. So I can say here the charge of Q3 plus Q4 together on the second rod, that is B rod, is equal to Q. Now solve these two to get the value of Q3. So to get this one, what I can say, directly add it. So Q4 get cancelled. This becomes 2Q3 is equal to nothing but minus 2Q minus Q, that is becomes minus Q. So if you solve it, what you are going to get? If you solve this one, so Q3 is equal to how much you are going to get? Minus Q by 2 charge you are going to get. Now look at the options. Q3 value, which is Q3 value minus Q by 2. First option also having. Second option also minus Q by 2. Third is no. Fourth is no. So third and fourth option not correct. So we have answered the first option and second option. So you have to check in that next one. What is the next one? Q5. To get the Q5 value, so the Q5 charge is on the third rod, that is C rod. Apply the same concept. Okay, in this case, this is C rod, so I am taking, okay, this is EC. Electric field at the center of EC is equal to, take it as 0. So based on this one, here also, due to 3Q, there is electric field at the center of this rod towards the right direction. So I am writing directly in terms of charge. Here 3Q is providing the electric field towards the right. Right side electric field is positive, left side electric field is, I am taking as negative. 3Q produce the electric field at C point towards the right, so plus 3Q. And next one, Q. Okay, because Q3, Q4 together producing the electric field on this third rod towards the right side. So Q is also producing the electric field towards the right side. That is also plus. Next, that is third rod, that is C rod. C rod contains two charges, Q5, because we need to find the Q5 value and only Q5 value. So Q5 is from the point, it is towards the left. So that means due to that, the electric field also towards the right side. So it is positive, and Q5 minus. Last charge is Q6. Q6 is towards right. So electric field will be left side direction, that is minus Q6. Total is equal to 0 because according to constant. Because okay, 3Q by A epsilon naught, that is all will be get cancelled. So directly I can write here. So this becomes 4Q is equal to, okay, this term make it that side, that it becomes Q6 minus Q5. Now according to the third rod, what is the total charge of the third rod? That is equal to nothing but Q5 plus Q6. Q6 is equal to capital Q. So I can write total charge Q is equal to sum of the Q6 plus Q5. So if you solve this one again, we require Q5. So what you do is minus it, minus, minus, minus. So plus Q6 can be eliminated here. after elimination of that Q6, how much you are going to get? This is nothing but 3Q is equal to minus, okay, 2Q5 here. So that means what is Q5 value? Q5 is equal to minus 3Q by 2 is the value you are going to get. So if you see the options, which is the minus 3Q by 3Q by 2, the first option contains minus 3Q by 2, second option contains minus 5Q by 2. So the correct answer for the question is, okay, first option is correct, minus Q by 2 and minus 3Q by 2. In the same way, you can able to calculate for the first phase also, last also, and you can calculate any one of the charge value in terms of given distribution of the charge using electric field concept and using electric field due to sheet concept. Now we are going to the discussion of next problem. The problem is given a long cylindrical volume contains a uniform distributed charge of density rho coulomb per meter cube is given. The electric field inside the cylindrical volume at a distance of x equal to 2 epsilon naught by rho meters from the axis of the cylinder they are asking. In this case, the charge distribution, if you see the cylinder, they given volume charge distribution, that is rho is called volume charge distribution. And already we previous class we discussed, whenever you taken any cylindrical, okay, charged surface, that means cylinder if you taken, in this case the charges are distributed along the lengthwise we can say, and also along the area wise also we can say, lengthwise, right? In this case, using Gauss law, the electric field intensity due to this one is equal to lambda by 2 epsilon naught r v1, where r is the distance of the point where you are going to calculate the electric field intensity. Suppose if r is the radius of this cylinder, if you say, if you are calculating the electric field intensity on the cylindrical surface from the center of this cylinder, in this case r is the distance of that effective distance, if you say, electric field is equal to lambda by 2 pi epsilon naught r, I can say, where lambda is called as charge occupied per unit, that is Q by L. So here lambda is called linear charge density, but if in our question they given volume charge density here. What charge density? Volume. So you have to convert this one into volume. So E is equal to that lambda I am writing in terms of Q by, that is 2 pi epsilon naught R into L I am writing. Q by L is called as nothing but lambda. What I am doing is multiply and divide with R by R for getting the relation. If you multiply divide with R by R, now this I can write as Q into R by, this is I am writing as 2 epsilon naught, I am writing separately, this pi into R, nothing but pi R square. What is pi R square? Nothing but area of the cylinder. Whenever you take the cylinder, it is having area. The area of the cylinder is pi R square. You can write pi R square into length of that. So area into length becomes what? Volume. So in this case, I can write electric field intensity E is equal to, this is the charge Q, this is the term called as volume. The total term will becomes charge occupied per unit volume, that is Q by pi R square. Nothing but we can write as volume charge density. So I can write here rho by 2 epsilon naught into remaining is R. So if electric field is a vector quantity, if you say, this is directly proportional to R. So rho by 2 epsilon naught R is a formula for this, in this case of volume charge distribution. So what distance they are asking electric field? This is the distance at a distance of R, but they are asking at what distance? X equal to 2 epsilon naught. That means this is a place of R, the distance of the point you have to take as 2 epsilon naught by rho we have to take. So that means electric field intensity at that point, electric field intensity is equal to, that is, so I am writing here, electric field intensity is equal to rho by 2 epsilon naught into R is the formula. So in the place of R, I am taking as X here. Okay, X is the formula. What is the X value here? Because they are asking at X distance. Rho by 2 epsilon naught into X value in the question they given very clearly, that is 2 epsilon naught by rho. If you cancel this one, rho get cancelled, that is equal to electric field intensity is equal to how much? 1. Units is volt per meter. So it is one of the numerical based question. That's why they given the film black here. The answer for the question is how much? 1 volt per meter is the answer to the question. This is one of the important model of conversion of the formula into required formula. Then you have to solve the question. This is asked in the previous one of the IDG mains and advanced level question they asked in the previous. Now next question is similar to the previous one. theoretical question, graphical question. So what is the question they given? For a uniform charge conducting solid cylinder of infinite length. We taken one of the cylinder of infinite length one, of solid one, and which is conducting one. And which of these graphs shows the variation of E and R, electric field versus distance relation graph, which is the correct option they are asking. Anyway, you know that it is which type of okay cylinder? Conducting cylinder. Conducting means whenever you take any conductor, electric field inside always 0. So that means from the center of the cylinder to up to the surface, electric field always 0. So there will be no electric field. So if you see the first option, from the center in the graph R versus T graph, this is origin, this is center, okay, on the surface. From the center to on the surface there is no electric field, so this may be correct. Second one, here also from center to surface there is no electric field, that may be also correct. And third one, center to the surface there is electric field, so this is not correct. Next one, fourth one, center to surface there is electric field, so it is not correct. So in the first and second option we are having our answer. So to identify the relation, you know that electric field due to any cylindrical surface is nothing but lambda by 2 pi epsilon naught r, where lambda is constant, 2 pi is constant, epsilon naught is constant, means E is inversely to r. So which of the option is correct? You can check it. This is inversely to square of the distance, inversely to r. So which option correct? A is wrong and B option is correct answer for our question. Now next question, also one of the question given in the previous competitive examinations, that is mains examinations. What the question is given? They given electric field in terms of vector form 4xi minus y square plus 1 j cap Newton per coulomb passing through the box as shown in the figure. This is one of the boxes given. Through this box it is passing. The flux of electric field through the surface. Two surfaces given, A, B, C, D. Which is A? This is A. This is B. This is C. This is D. Across this A, B, C, D and B, C, G, F. B and this is C, G, F. And the flux across the first surface is, across this one is given as phi 1 and across the second one is given as, okay, and the second surface is, that is phi 2. And they are asking to find the difference between the flux across these two areas. So basic formula for the flux is equal to nothing but it is a product of electric field into area vector. So in this case vector form is given, that's why you have to use the dot product of this one to find the answer. What is the electric field? So first you take the electric field. So electric field is equal to 4x I cap plus, that is y square plus 1 j cap into area vector. The area vector you have to choose according to the concept of that direction of that vector. So in this case they are asking first flux across A, B, C, D. That is nothing but we can write as flux 1. Flux across the first we can write. So what is the flux across the first one? The flux across the first one is equal to nothing but what is the electric field here? The electric field in this case can be written as like this, that is nothing but, okay, electric field into area. What is the electric field here? 4x I cap plus y square plus 1 j cap dot area. So what is the area? If you observe this one, in this case the area vector, which is the ABCD, if you look at this one, ABCD, this is the area. So the area vector is always normal to the surface area. This is the direction of the vector which is parallel to the axis. So what is area? Area is equal to nothing but length into breadth. What is the length here? This is nothing but length. What is the length along x-axis? That is 3 into this is nothing but breadth, that is along y-axis, that is 2. That is I can write as 6 k cap area of this. So I can write that is 6 k cap. So anyway, if you take on the dot product, I dot k is equal to 0, j dot k is equal to 0. So the flux across the first surface is always, that is 0. Next, if we go to the another phase, what is the another one? BCGF. The flux across BCGF is equal to, that is second phase, is equal to what I can write similarly, E dot A, same concept. What is E? 4x I cap plus y square plus 1 j cap and dot area vector. So what is the area vector for the BCGF? This is BCGF. Now this is the flux across that one. So area always normal to the surface. This is the direction of the area vector. So this area vector is equal length into breadth. What is the length? I can write this area. This is the length I can take as length, that is equal to how much along the y direction, that is 2, into this is the breadth I can take it as, that is nothing but how much, that is also 2 because z axis. So 2 into 2, nothing but how much, that is 4. What direction this is? This area is along x axis, so I can write as I cap. So this area vector is in the direction of 4 I cap. So that means I can write as this is 4 I cap. If you take on the dot product of this one, I dot I becomes 1 and j dot I becomes 0. So second term anyway becomes 0. So remaining is 4x into 4. I dot I is 1, that is nothing but 16x here. So what is x value? X is the distance. Okay, x is the distance. That means what position we need to calculate along x axis. What is the distance of the point of the face? The face is from the origin. The point is a distance of, what distance it is? 3 is the distance of that. That means 16 into 3. Nothing but we are going to get 48. So in terms of numerical, 48.00 we can write. So the flux across BCGF, that is nothing but second phase, is equal to, we can write as 48. So what is the difference in the flux? According to answer, that is nothing but phi 1 minus phi 2. Okay. Phi 2 is equal to how much we can write? That is nothing but 48.0. That is according to the units. That is Newton meters square per. This answer the question. This is given the previous competitive examination. The next problem given based on flux concept, that is cubical surface based concept. A point charge is given, that is plus 12 microcoulomb, is a distance of 6 centimeters vertically above the center of the square of side 12 centimeters as shown in the figure. The magnitude of electric flux through the square will be, how much value the magnetic flux through that surface area they are asking to find. First, to solve this one, this is one of the plate is given, how much length? 12 centimeters, width is also 12 centimeters, but the charge is placed at what position? A distance of 6 centimeters from the center of the plate is given. So according to Gauss theorem, if you want to apply any Gauss theorem, it is compulsory that you have to construct a Gaussian surface which is similar to the body shape. So I can take here one of the cubical structure I am taking here. This is the way I am taking here. Now if you observe this diagram, in this case, this is the bottom portion. This is the portion which you are seeing in the diagram. This is the portion which is having 12 centimeters length and 12 centimeters width. 12. Okay, thus it is having length 12. If you want to take the diagram bigger one, we can take the diagram little bigger so that it will be easier for us. So in this case, I can write this is 12 centimeters length and this is 12 centimeters. Now we have a charge here. The charge is, actually it is a cube. Cube means, that means in this case the charge is a distance from the center of this square. What is the distance of this one? That is, the charge is placed at 6 centimeters distance. From here to here, the distance is 6 centimeters. If you see the diagram here, 6 centimeter distance. So why I taken the here cubical structure? Because if you want to apply the Gaussian surface, the charge has to be taken inside the Gaussian surface. Okay, so that you can able to explain, because this is a plate. So if you want to construct the Gaussian surface, you extend that plate as a cubical, okay, a structure. So you can see like this. So in this case, the height of this one also becomes 12 centimeters cube. I can construct it. If you construct it as a 12 centimeter cube, okay, that means length, breadth, height is same. In this case, the charge which is placed at a 6 centimeter becomes half of the height of that cube. Half of the height of that cube. That means I can say here that is nothing but half of the distance of that. Now, what the question they're asking, what is the flux enclosed in that? Flux equal to E into A, electric field into area of cross section, or otherwise we can write as Q by epsilon. But in this case, whenever the charge is at the center, you know that the charge is covered by 6 faces, 1, 2, 3, 4, 5, and the front side is, that is 6. Total 6 faces it covers. So what is the flux across each face? The flux across each face is equal to Q by 6 epsilon naught is the formula for that. That you know the previous concepts. Now apply here. What is the flux across each face? They are asking. That means they are asking to find the magnitude of flux passing through the square will be. Square will is, this is the square, this is one of the face of the cube. It becomes one of the face means Q by 6 epsilon naught. I convert as Q by 6 epsilon. What is the Q value given in the question? Very clearly 12 into 10 power minus 6 by 6 into epsilon naught. So epsilon naught value, either you can substitute 8.85 into 10 power minus 12 also you can substitute, or also you know that 1 by 4 pi epsilon naught value is equal to how much? 9 into 10 power 9 value. From the epsilon naught is equal to what I can write? Epsilon naught is equal to 1 by 4 pi into 9 into 10 power 9 also I can take. So take the reciprocal value. That means flux is equal to so what I can write here, the flux is equal to, that is flux across that one is equal to what I can write, that is 6 2s are, we can cancel 2 into 10 power minus 6 into 1 by epsilon naught I can write as 4 pi into 9 into 10 power 9 I can write. Now calculate this value. Okay, after calculation how much you are going to get? That is nothing but 72 pi into 10 cube we are going to get. So 72 pi, what is pi value? 22 by 7 you can take, or 3.14 you can take. 72 into 3.14 into 10 cube by 2. Nearly 72 3s are nearly 210, that is nothing but nearly it comes around 220. So if you check the answer for this question, nearly you are going to get 228 value you are going to get, nearly 228 point something. The decimals will be, you can cancel the two decimals, one decimal will be there. 72 into 3 like, that is nearly we are going to get 228 value. So this is the answer for your question according to that. So in this case into 10 cube is given, so you can write into, okay, 10 cube in the form of, because answer 10 cube in the form of 10 cubes they given. So 228 into 10 cube. The point should not cancel, so keep it in mind. This is, you keep it like this, otherwise I'll write once again. So this answer you can write as flux equal to, that is this value nearly is equal to 228 if you taken into 10 is the answer. So this is one of the question important to note. Now this question also given in the previous competitive examination, previous mains examination. So what is the question based? It is based on the flux concept. So a charge Q is placed at one corner of the cube. So look at the diagram. This is the charge where we kept in the cube. Now they're asking the flux of electrostatic field E through the shaded area. So you can see this is the shaded area. Through this area they're asking to find the flux. So if you see the diagram of this one, the shaded part, if you remove this side of the shaded part and if you keep it on the surface, that means here I can replace that. That means it becomes one side of the cube. One side of the cube, that is the constant. So in this case, the shaded part, half of the top part is shaded and half of the side part of the cube is shaded. So this shaded part I cut it and I can replace it to the side of the above shaded part. It becomes as one side of the cube face it becomes. That means what is the flux across the one face of the cube? If we calculate, that is the answer to the question. But here the charge, where the charge is present, the charge is present at the one of the corner of the cube, not at the center. Corner means you have to consider the Gaussian surface. Already you know that if you have a charge at the one of the cube surface, in this case, okay, this is the cube if you say. So if you are placing the any charge at the one of the corner of the cube, so this is the one place if you are keeping the charge. If you want to surround this charge, it has to be inside the Gaussian surface. So you take the cubes like this. So here one cube is there, second cube, and you have to keep the third cube, fourth cube like this, and below and above also you have to keep the 4 cubes. Totally 8 cubes you have to keep. So that what happens, the charge will comes inside the Gaussian's cube. Okay, because actual cube is this, the charge is at the corner. I can cover with the similar cubes. I can take side. This is second cube I am keeping side. Fourth one is I am keeping side. third one is I'm keeping other side, so base will becomes 4, and top also I'm keeping 4, total 8 cubes I'm taking here, and in this 7 is imaginary Gaussian cubes, 1 is original cube. So that means the charge is present inside the big cube, which contains total cubes are 8. So what is the flux across each cube? Total flux across is equal to q by epsilon naught, but the flux across each cube is equal to how many cubes, which imagined 8 cubes. So that means flux across each one is equal to 1 by 8 epsilon naught, it becomes 1 cube. So that means the total flux across this 1 cube due to this charge is equal total is equal to how much? Q by 8 epsilon. But they're asking only shaded part. Shaded part means which side the shade is coming? The shaded part is coming only one side, that is, according to the diagram, you can say the shaded part is only coming either upwards or downward direction. This is the direction of shaded part. So only this part they're asking. This part they're asking means already according to the concept one side q by 8 epsilon naught. So which contains, this is totally how many cubes will be there? This is totally 8. This total value, how much you are getting it? Q by 8 epsilon naught. From that one of the side they are asking, one side means you have to take it as remaining 3. That means phi dash is equal to 1/3 of q by 8 epsilon naught here. 3 sides. That means what is the flux across that shaded part will become equal to q by 24 epsilon naught here. Totally the charge is covered by 8 cubes, so flux across one set of the 8 cubes is equal to q by 24 epsilon naught. So if you are still getting confused, we can go for the diagrams here. This is one cube, this is second cube, like that. This is the 4 cubes I'm not touching here. These are the cubes which are actually must be touch each other, so that this is the way the cubes. So in this case you need to understand here the total flux across these 4 cubes value is equal to how much? That is q by 8 epsilon. Now what is the flux across one phase means? You have two remaining 3 phases. That means 4 types of 4 sides of this one. That means the remaining is 3 phases are there. So 3 phases means what is the flux across that one? 1 by 3 times of q by 8 epsilon naught. It becomes. We have to take 3. We have to avoid the 3 phases, right? That 3 phases, if you avoid it, you will get the one of the face of that cube, that is equal to q by 8 epsilon naught. That is the way you have to take. So in this case, I can avoid this area. So answer for the question is B option is correct for the question, q by 24 epsilon naught. Now this one also given in the previous competitive exams. A cube of a cube is placed inside the electric field given 150 y squared j cap along y axis given. The side of the cube is 0.5 meters is given, and they are asking it is placed in the field. The cube is placed in the field. The charge inside the cube is. They are asking the corresponding value equivalent of charge, because they are not given any charge in the diagram. That means they are asking the flux related charge in the cube estimated will be how much. So if you observe this one, this is the cube which is structure is given very clearly. You can see here electric field. What is the direction of the electric field here? That is y axis. So that means the electric field originated from the origin from here in this direction. This is the direction of the electric field. Now if you observe here with corresponding to this, the electric field will passes across each phase as they're looking like this. So the electric field enters like this, you can say, and the electric field inside passes like this, and from the surface it comes out like this along y direction, because j cap is given component. So in this case you need to understand the cube contains total 6 sides, 6 faces. So area, because flux is always maximum normal to the area, and along the surface is 0. So in this case, if you observe this line, so here this is the surface and this is the electric field, both are 90 degrees, so flux will be maximum here, right? So here also this is the area and this is the normal, so there may be flux also here. Next, that is there is a flux. Now if you observe this one, this is the area vector, and this is the direction of the electric field vector. So both are okay. In this case, what is the angle? In this case, the angle is equal to nothing but is 90 degrees. So, but if you come across a case of area vector based, so in this case, if you come across the area vector based here, this is the area vector, and that is the direction of the electric field. Both are parallel, so theta equals 0 degrees, not 90 degrees. Don't take with respect to surface. So here also you take the same thing. Electric field is upward direction, so area vector also upward direction, area. So here this, in this case, the area vector is downward direction, area vector, electric field is upward direction. So both are 180 degrees here. So remaining all the cases, what happens? Electric field is upwards, area vector is okay like this. So in this case, all the cases, electric field and area vector is perpendicular to each other. So if you are getting confused in this, you can go for bigger diagram so we can understand clearly. So this, the cube contains total 6 faces, right? So first area, this is the way the area vector of this one. So electric field is vertically upwards. So along this area, the electric field is passing like this. So this is electric field, this is area vector, both are 90 degrees. So flux across this one is equal to 0. Similarly, if you see this face, area of this one is in this direction, electric field is passing in this direction. So here also 90 degrees. 90 degrees means what is the flux across this one also is equal to 0. Now here also, if you come across the case of in this, okay, in this side of the front side which you are looking, so I am taking the side of this line. This is the line. If you see this face, electric field is upwards and area vector is outwards, and back end also area vector is inwards. That means out of the plane of the board one area and into the plane of the board another area. These two are perpendicular to this electric field. So only our concentration is two faces. The shaded part, this is the bottom shade, this is the bottom area and top area. These two, in this case, electric field is upwards, area is also upwards. In this case, area is downwards, electric field is upwards. So in these two cases, we have a flux. Flux is not equal to 0 here, flux is not equal to 0 here. Now to calculate the flux value, come to the case of, this is the first area I am taking here, this is the bottom one I am taking as 1 and upper one I am taking as 2. So flux across 1 is equal to, formula is E into area, electric field vector into area vector. What is electric field vector? That is 150 y square. What is y? Distance. So y is the position of that electric field. So if you taken in the diagram, if you see this is the origin, the bottom face is at what height it is with respect to y-axis? Y is equal to 0 height. Now second phase, what is the height of this one? The second phase is at a distance of y is equal to a, because they given very clearly the question, the cube is okay, side of cube is 0.5 meters given, so you take the side of that one as a or any length L like that. That value is equal to how much? 0.5 meters is given. So phi 1, the flux across the first phase is equal to, according to formula, 150 y square into j cap into area vector. What is area? Length into breadth. What is the length? 0.5. Breadth is also 0.5. So that is nothing but we can write as 0.5 whole square. 0.5 whole square. Area vector. What is the direction of that one? Negative y axis. That is minus j cap. Negative y direction. So here j dot j is anyway 1. No doubt in that. But what is the y value? In the case of here phi 1, the y value is equal to 0. If you put the y value 0, the total flux value becomes equal to 0. So that means there is no flux enclosed in this one. Next, what is the flux enclosed in the second part? Topmost of the cube. This is the shaded part. What is the flux enclosed in this? In that part, the flux in the second is equal to electric field across that one into area vector of that one. So what is electric field? Same formula, 150 y square, that is j cap, and dot area 0.5 whole square, that is in the same direction j cap. So if you observe, what is y value? Whenever you taken the top shade, what is the distance of this one? This is at a height of from here to here. This is the height. What distance that is? Already we taken, that is y is equal to a, and value is 0.5. So that means this y value is equal to how much you will take? 0.5. That is nothing but 150 into 0.5 whole square j cap dot 0.5 whole square j cap. So anyway, j dot j is 1. So I can write 150 into 0.5 whole power 4 into. You got 0.5 whole square, 0.5 whole square. So this I can write as 150 into 0.5 means 1 by 2, 1 by 2. Okay, whole power 4 I can. So if you solve this one, how much you are going to get? This value you are going to get as 1 by 2, that is nothing but flux across second phase is equal to 150 by 2 power 4, nothing but 16 here. 150 by 16, this is the flux you got. Okay, so but what they are asking, the charge inside they are asking. What is the concept of this flux? Flux is equal to charge q by epsilon naught times the charge enclosed in that. So I can write charge is equal to nothing but 150 by 16 epsilon naught. So if you substitute the value of this one, 150 by 16 into this value is equal to how much you can write, that is 1 by 4 pi into 9 into 10 power 9 we can take. And after solving this one, we are going to get this value nearly, after calculation, we'll check it that. After calculation, this value I am writing directly here, 8.3 into 10 power minus 11 coulombs here. So this is the charge enclosed in the cube. We can able to explain. So this is the way you need to understand this type of model questions.